Hello friends, in this lesson we are going to learn about the human-machine interface, or in short the HMI display devices. We will use the Siemens KTP400 model as our HMI device, which is a very standardized model at Siemens. After a short introduction, I will explain my HMI hardware. Then we will see how to link my HMI. Then I will start up my HMI with a simple project. Up until now, at this industrial automation pyramid, we have seen how a PLC can be connected to computers or electrical instruments to control them. As you know, we are using a Siemens S7-1200 CPU and also the TIA software which can program it. You might know that the HMIs are widely used besides the PLCs. Nowadays, there are many types of HMI devices. Each HMI device can be programmed with suitable software and can be connected to PLCs to visualize industrial processes. In this tutorial, we will use a Siemens KTP400 basic panel as our HMI, which can be programmed with the TIA software. Let's start with HMI hardware. The first part is its touchscreen interface. At the bottom, here are 4 buttons that we can use to assign some functions to these buttons, which could be global or local. The global function performs the same action throughout the process. It does not matter which screen is open. Local function means the button can have different tasks on different screens. On the back side, here we can see the device information. For example, its type or article number. When we are defining this device in TIA, it's better to check this article number. Here we have some important ports. This is the power supply port. Then we have a USB port. In the USB port, we can either connect an external mouse or keyboard or a USB memory stick, which can be used to transfer a program. Here is a Profinet interface port. With this port, the HMI connects to PLCs, or we can transfer our programs into the HMI with a LAN cable. Now let's see how to link the PLC with HMI. We have seen how a Siemens S1200 CPU connects to a computer via a LAN cable. Similarly, we can connect this HMI to personal computers. Also, with a LAN cable, the PLC and HMI can connect together. The base point in a network is that the IP addresses must be different for each device. For this HMI, we can use TIA software to set the IP address, and also we can put the IP address within the HMI interface. Alright, when the KTP400 is powered, these 3 choices appear on the HMI screen. The transfer mode can only be activated when at least one data channel has been enabled to transfer a program to HMI. For example, when TIA is connected to HMI and wants to transfer a program. The start choice is used to start the project on a HMI device. And the settings choice can be used to start the settings page of the Start Center. Then you can change the HMI settings like its IP address, or recalibrate the touchscreen, or define a password. You can learn these settings and other basic information from this manual of Simatic HMI for basic panels. For example, in this section, configuring the device, you can see how the device settings can be changed. Alright, let's see how an HMI device can be inserted into the TIA software. This is my PLC hardware. I have used this PLC input and this output in this simple program. We have learned these basic instructions to program a PLC. Now click here to add a new device. Now click on the HMI item. Here we can find HMIs that can be programmed with TIA software. Let me match this article number with my HMI. Well, click on OK. After that, this window will appear. This is the device wizard window, which can be used to define some settings for the HMI. We can click on cancel to insert the selected HMI without any predefined settings. But let's see what the 6 steps of this window are. In the first step, it asks for the PLC connection. Here I have defined only one PLC for this project, so I can select it here. In the second step, screen layout, we can select a date, time and logo to see them on the HMI screens. Also, we can change the screen resolution and its color. The next step is alarms. So if you want to have predefined alarm screens to show some system events, you can select them here. If you don't want them, you can remove them because to have these screens are optional. Let's go to the next step. Here we can determine how many screens we need. This is the root screen. If we need more screens besides the main screen, we just need to click on the plus sign icon. We can also delete the screens and rename them from here. Click on the next icon to go to the system screen step. Here we can select which system screen we want for our project. These system screens include Simatic PLC, diagnostic view, project information, user administration, system information, and some operating modes, some language switching options, and stop runtime options. In the next step, we can use some common buttons on the left or right side or at the bottom of our screens. These buttons are used to exit, change language, back to the start screen, and show the logon dialog. Finally, click on Finish icon. As you can see, the HMI device has been inserted inside the left list. In the Screens folder, we can see some screens which have been created based on our initial settings. The main screen is the root screen, where the HMI starts its work from that. Suppose this project is transferred to the HMI. If we click on this button, the screen 0 will be shown. Similarly, we can select screen 1 or screen 2 or back to the previous screen. These settings are created based on our initial settings. For example, this is the screen system which has been selected before, or this is the user administration screen, and also this is the system information screen, which shows us the HMI device type and also its connection type with a PLC respectively. If you remember, the base point in network connection is the IP addresses. Each device must have a unique address. To check this item, click on Device Configuration. Click here to see the HMI connection properties at the bottom. As you can see, the HMI is connected to a network with this IP address 192.168.0.2. If you remember, at the first step of the previous wizard window, we have connected the HMI to this PLC. If we click on Devices and Networks, we can manage devices connection. Here we have a PLC and HMI which are connected together with this network. Also, we can create this network manually. Let's see my PLC IP address. As you can see, it's different from the HMI IP. Alright, on the left side we have some screens. From the right list we can use some graphical objects which can be inserted into each screen to visualize our PLC parameters. Now let's define and do a simple project. We are going to use the PLC tags in the HMI. This is a simple PLC program. We want to define a circle on the HMI which, when the motor is on, its color changes to red. Alright, let's start from the first step. You can write this simple program. Let's transfer it to a virtual PLC. Now let's define my HMI device. Click on Cancel to have an HMI device without any initial settings. Let me connect the PLC and HMI together. As you can see, the HMI IP address and the PLC IP are different. Well, there is only one screen without any object. Let's insert a circle. If you click on each inserted object, then we can see its properties at the bottom. Here are some properties of the inserted circle. Select the Animation tab. We want to change its color based on the PLC output. Click here. Here we need to write an address or select that from here. Let's select the motor tag from my PLC. As you know, this tag has two states, 0 or 1. Let me change its color to red for state 1. Now let me save the project. Well, we can use simulation instead of a real HMI. So let's select HMI and click here. Alright, now we can test our project. Let me sort these windows. Let me use the force table to change the start contact. As you see, when the motor is turned on, the circle color changes to red automatically. Now let's review the necessary settings to make a connection between S7-1200 CPUs and Factory IO. Then we will see how an HMI can be programmed besides a PLC. Now let's see how we can link the PLC with my HMI device. I already explained how to connect Siemens S7-1200 CPU to a computer with a LAN cable. Similarly, we can connect this HMI to a computer. A PLC can be connected to an HMI using a LAN cable as well. The base point to remember is that in a network, each device must be assigned a different IP address. In this tutorial, we can use one LAN cable to transfer programs and make connections, but we will need to plug and unplug the LAN cable from our devices simultaneously. Another way is to use an industrial Ethernet switch or a simple modem to connect all devices as long as each device to have a different IP address. Alright, first we have to configure our PLC in the TIA. Then we need to make a connection between our PLC and Factory IO. In the protection settings, we need to have full access by selecting this option, Permit Access with put/get communications from remote partners. Also, let me change the start address of my PLC input addresses from 0 to 10. Therefore, I will be able to use I0.0 to I0.9 input addresses in Factory IO. The main point is a physical input address from the PLC cannot be used in Factory IO, but we don't have this limitation for the PLC outputs. Also, I need to know my PLC IP address. Now let me use the SR instruction to turn on off an output with two digital inputs. Also in Factory IO, there is a conveyor which can be turned on with the PLC output, and also these two push buttons can be connected to my PLC inputs. To make a connection between Factory IO and my PLC S7-1200, let's go to the File menu and then to Drivers. First, I have to select S7 Siemens 1200/1500. In the configuration, I have selected the corrected PLC type and entered my PLC IP address. Also, I have selected my network adapter. Here I have connected the two push buttons to two inputs of my PLC, I0.0 and I0.1, and the conveyor is connected to the PLC output, Q0.0. Now I am going to use these two push buttons to turn on off the output. Pay attention, because the stop push button in Factory IO is normally closed, I have to use a normally closed contact in my program. Until now, I can turn on off the PLC output from Factory IO and its real inputs. Now let me show you how I can connect my PLC to the HMI and use that to turn on off the PLC output. First, I have to add my HMI to the TIA. So I click on the Add New Device. Here I find my HMI model. This window can help us to define initial settings. Let's click on Cancel. As you can see, my HMI has appeared on the left side. Alright, to make a connection between the PLC and the inserted HMI, I click on the Devices and Network. Now I can connect the HMI to my PLC manually. Let's see the HMI IP address. The main point is the IP address of the HMI and my PLC must be different. Now let's go to the Screens folder to design a simple HMI screen. First, I use a simple circle to show the PLC output states, like in the previous video. Now let me insert motor text below the circle. Alright, how we can turn on off the PLC output from the HMI? Pay attention, HMI cannot change the PLC inputs, but it can modify my PLC memory. So I can use the two contacts with a bit address of the PLC memory, which their status can be changed by the HMI. Well, based on this program, I will be able to turn on off the PLC output from my HMI, Factory IO, and also the PLC inputs. Now let me complete the HMI screen. I am going to use two buttons and connect them to the two last inserted contacts with M1.0 and M1.1 addresses. Here I can use the set and reset function to change the PLC bit memories. I will explain the buttons in the next videos. Now you complete the HMI screen the way I did. Alright, now let's test the project. First, I transfer the program to the PLC. The TIA needs to compile my program. Now let me click on Load to transfer the program to my PLC. Here pay attention to the PLC LEDs when the program is transferring or when the CPU is in a stop or run mode. Now I am going to load the HMI program. Let me click on Search. TIA software has found my HMI. If I click here, the detected HMI starts flashing. Now let's transfer the designed screen to my HMI. First, TIA needs to compile the designed screen. Now let me click on Load to transfer the designed screen to my HMI. Also, let's connect the Factory IO to my PLC. Now let's test the project. Now the plant in Factory IO and my HMI are linked to my PLC. Based on my program, the start push button can turn the output on. As you see, the conveyor and the first LED are turned on and the related green circle changes its color to red. Also, I can stop the conveyor with the stop push button. Similarly, I can turn on off the output with these real switches. I can use my HMI to turn on off the output as well. I can activate the program monitoring option to see what happens in the PLC program. I hope you have understood how a PLC can be connected to a HMI and Factory IO. Now let's see how a PLC takes commands from an HMI. Then we will see what basic objects are available to design the HMI screens. Finally, we will do a simple monitoring project. Let's start with the previous program. So here we have a PLC and an HMI which are connected together in this network. Let's see the PLC program. In the previous video, we have seen how a red circle can be designed on the HMI to show this output is on. Now we are going to see how we can turn on this output from the HMI panel. Pay attention, the address of this contact is I0.0, which is an address of the PLC input. Naturally, the HMI cannot change the physical voltage at the PLC inputs, but they can modify and store values on the PLC memory. So to turn on the output from an HMI, we need to use contacts with a bit of memory of PLC. Okay, the HMI is able to change the status of this contact to turn the motor on. Let's define a suitable tag for this address. The HMI will use this tag to turn on the output. Based on this program, the output motor can be turned on by the PLC input and also from the HMI. Now let's transfer this program to a virtual PLC. Now let's design the HMI screen. Here you can see the circle from the previous video. As you can see, this circle is linked to the motor tag of my PLC, and if the motor is on, this circle will be turned to red. Let's insert a switch from the right list. Now at the bottom, we can change the selected switch parameters. Click here. Now click here to select this PLC tag which has been defined before. Also, let me change the color of the switch for its two states, off and on. Now let's test the program. Let me get back to the PLC program and sort the opened windows to have a better view. As you can see, we can turn on the output from the HMI. Alright, let's see what the basic objects are. On the right side, here we have line, ellipse, circle, and rectangle, whose parameters are similar to each other. Also, we can use text on the HMI screen. With the last item, graphic view, we can insert any shape of the TIA library or from our computer, such as this logo. Alright, when each object is selected, its parameter can be changed at the bottom, such as changing their color or line width. Also, the object's position can be changed manually or from here by entering a number. Each shape has some specific parameters. For example, we can change the radius parameters for circles but not for rectangles. Here we can use predefined styles for objects. In the last segment, we can change object names and determine their layers. But what is a layer? Now let me change the object's layer. Now click on the screen. Here we determine which layers to be visible on the screen, and when a layer is inactive, all its objects is removed from the screen. Now let's see the animation tab. Here are three important choices. The first one is appearance. Remember, we learned this part for the circle. The next choice is visibility. Let me select the motor tag here. As you know, this tag has only two states, 0 or 1. Let me change this value to 0. Now let me read this comment. If you have selected the visible state, for example, the display and operating objects remain visible as long as the tag value is within the start and end value of the range of values. The object is hidden when the tag value has exceeded the end value. So when the motor tag is equal to 0, it will be in the defined range. So the selected text motor is off will be visible, otherwise it will be hidden on the HMI screen. In the same way, I want to show this text when the motor is on. In this case, when the motor is off, the selected text will be invisible. Otherwise, it will be visible. The third choice is movement. Let me select the horizontal movement option. Here the HMI can use a PLC memory value to move the selected object. Let me use the select instruction. Well, this program will move 0 or 100 to this PLC memory with this tag. Its value is used for the rectangle movement on the HMI screen. Let's transfer this program to the virtual PLC. Now let's use the defined PLC memory here and then simulate the HMI screen. Alright, let's test this HMI screen. As you can see, when I press the switch, the motor is turned on. After that, the HMI changes the circle color, shows the motor is on, and moves the inserted rectangle. Now let's define a practical project with Factory IO. We want to write a PLC program to turn on a belt conveyor and to show the number of moved boxes on a digital display. Here is a selector to turn on the conveyor and a digital display to show the number of the moved boxes. After that, we are going to design an HMI screen to show boxes position and the number of the moved boxes. We can detect boxes position with these 5 sensors and count the number of the moved boxes with the last sensor. Well, for the PLC program, I have defined these tags, and this is the PLC program. In the first network, the conveyor is turned on by a PLC input or HMI screen. In the next network, a counter counts the moved boxes. You are expected to be able to design this plant with Factory IO and write its PLC program. So let's do the HMI part. Now let me connect the HMI to the PLC. Now let me use a switch and connect it to the PLC memory in my program to turn the motor on. On the right side, from the graphics panel, we can find suitable shapes. Let me insert a conveyor. In the same way, let me insert 5 boxes. Well, I connect these boxes to the 5 sensors. So when each sensor is activated, the related box will be visible. Now, like the previous program, let's use a red circle anytime the conveyor is on. Finally, let's use an IO field to show the number of moved boxes. Now let me test my designed screen with Factory IO. As you can see, I can turn the motor on with the selector or from the HMI. Also, the position of boxes and the number of the moved boxes are shown on the HMI. It seems I need to use more sensors to improve the design HMI screen. Alright, I have decreased the distances between my sensors. Now let's do the previous simulation with the PLC and HMI. In the next video, we will continue designing the HMI screen. I will see you in the next video. Take care of yourself.